Welcome back to WAPC. So we can move to another section of atomic and nuclear. So the first question is the de Broglie wavelength associated with the electron of hydrogen atom in the ground state. So in this question they have not given any kind of data, but one point is that the electron of hydrogen atom in the ground state. So what's the energy of electron in the ground state? We know that energy is equal to minus 3.6 electron volt, because the ground state means n is equal to 1 by n square. By n is equal to 1, that means divided by 1, then therefore the energy is minus 13.6 electron volt. So how we can see, how we can connect this energy with the wavelength? We know that E is equal to h nu and E is equal to hc by lambda. So we have to find lambda, so hc by E. Okay, so and this energy is in electron volt, we have to change that to joule. Okay, we don't want to do that kind of old calculation. If the energy is in electron volt, it can be the wavelength can be found by a direct equation. Lambda is equal to 12.27 by energy, root of energy, 12.27 by root of energy angstrom. Okay, in here the energy is 13.6 electron volt. That the root of the magnitude, only considering the magnitude, that means the root of 13.6 is approximately will be lambda is equal to 12.27 divided by 3.68. Okay, root of energy, that means root of 13.6 is approximately 3.68. Okay, 12.27 divided by 3.68 approximately 4 point something. So in here our options is 3.3 Armstrong. Okay, 3.3 Armstrong. We can choose our option B as the correct answer. So moving to the second question. The following graph is related to the output of a photoelectric effect. Okay, so you need to understand or recall the properties which we discussed in the previous class, as about the stopping potential and about the current and about the intensity and about the frequency, which we discussed in the previous class. Okay, so let's go to the question. The following graph represents the variation of photocurrent with anode potential for a metal surface. Here I1, I2 and I3 represent intensities, and gamma 1, gamma 2, gamma 3 represent frequency for curve 1, 2, 3 respectively. Okay, the curve 1, 2, 3 is shown in figure, and the y-axis is photocurrent and the x-axis is anode potential. Okay, so here we can see two stopping potential. Okay, the first one is here, this is the first stopping potential and this is the second stopping potential, and from the graph we can say that the stopping potential of first one and the second one are same. Okay, so I1, I2, I are current and gammas are frequencies. Okay, so when we can say, that means the stopping potential is same, so what we can say from that? The stopping potential is depend upon, that means energy is depend upon frequency, correct? So frequency of 1 and 2 are same, so frequency is represented by gamma. So gamma 1 equal to gamma 2. So which option is correct? A and C. Okay, A and C both have gamma 1 equal to gamma 2. Now we want to discuss about current. Okay, this is the photocurrent made by them, and okay, 2 and 3 have same photocurrent, and photocurrent means by what? Photocurrent means by what? The current is depend upon the intensity. So intensity of 2 and 3 are equal, so I2 should equal to I3. Okay, I2 is equal to I3. none of the options have I2 equal to I3, but in the first option I1 equal to I1 not equal to I2, then I2 equal to I3, then must be I1 not equal to I2, and in the third option C I1 is equal to I2, so that must be an incorrect option. So first one, option A is the correct option. I1 is not equal to I2. Okay, so we can move to the third question. The period of revolution of an electron revolving in the nth orbit of hydrogen atom is proportional to it. So time period, how the time period depend upon the principal quantum number. Time period is directly proportional to n cube. Okay, not this equation down. We can move to the fourth question. The angular momentum of an electron in a hydrogen atom is 3h by 2 pi. Okay, the kinetic energy of the electron volt. So see, angular momentum is 3h by 2 pi. Therefore, mvr equal to 3h by 2 pi, and the standard equation is nh by 2 pi. So what is n? N is equal to 3. The kinetic energy of the electron and angular momentum of an electron in hydrogen atom is given. So n is equal to 3. So we need to find the kinetic energy of the electron in the third shell. So energy is equal to minus 13.6 by n square. N is 3, so minus 13.6 divided by 9, that is approximately 1.5. So option B is the correct answer. So you need to understand, or you need to study that equation. E is equal to minus 13.6 divided by n square is the fundamental equation which connect with the energy of a hydrogen atom. Okay, that energy can be converted into other nucleus also, because energy into z square gives the energy of an atom with the atomic number z. Okay, yes. So we can move to the fifth question. Fifth question is related to an experiment. Okay, a beam of fast moving alpha particle were directed towards a thin film of gold. The parts A, B and C of the transmitted and reflected beams corresponding to the incident part A, B and C of the beam are shown in adjoint. So this is related to Rutherford scattering experiment. Okay, what are the inference we get from this experiment? The most of the area of an atom is vacant. Okay, and most of the mass is concentrated in the center part called the nucleus. When the alpha particles bounce with the center part, it will bound back. That means the return back. Okay, and most of the area is vacant. That means most of the particle will goes into the particle. So A is the alpha particle which passing through the atom, and B is the particle which bounds with the nucleus of the atom. Okay, and C is the particle with the partially get deflected by the nucleus. Okay, so B dash will be maximum and C dash in C dash maximum. Okay, and in option A both the B dash and C dash are maximum, and in option B A dash will be maximum and C dash will be minimum. Okay, A dash will be maximum because A is the particle which goes through the area. Okay, that means most of the space of an atom is vacant, so the most of the radiation will go through the atom. So A dash is maximum. So we can delete option C. A dash will be minimum. Okay, we can delete it, and B dash will be minimum and C dash will be minimum. Okay, we can and C dash is average and B dash is minimum. Yes, and C dash can be maximum. So option A is wrong, and B dash is maximum. Option D is wrong. B dash never become maximum. So option B is the correct. A dash will be maximum and in C dash is minimum. Okay, so option B is the correct answer. So we can move to the sixth. 2 protons are kept. Okay, I am taking 2 proton. One proton and the second proton are kept at a separation of 10 nanometer. 10 nanometer. Okay, let Fn and Fe, the nuclear force and the electromagnetic force. So what is the range of nuclear force and electromagnetic force? Okay, we studied that the magnitude of nuclear force is very greater than what the force of electromagnetic force, we know that. But in here the range is 10 nanometer. Is this range is good for nuclear force? No, this range is very larger than a nuclear particles states. Okay, the nuclear particles are very closer to each other and the nuclear radius is approximately 10 raised to minus 12 and the nuclear particles are within the 10 raised to minus 15. So this is nanometer, that means 10 nanometer means 10 raised to minus 8. Okay, 10 raised to minus 8 is 10,000 times larger than this 10 raised to minus 12. Okay, 10 raised to 4 range, that means 10,000 times larger. Okay, that means that is a too far radius, too far distance. Okay, when for what? For the nuclear particles to exhibit nuclear force. Okay, so the nuclear force is very small. Okay, and this range is good for what? The electromagnetic force. Okay, the force by electromagnet is 1 by 4 pi epsilon 0 q1 q2 by r square. Okay, that r is good for that r distance r is good for the nuclear force. Okay, but so we can choose the nuclear force is very smaller than electromagnetic force. So option B is the correct answer. Okay. So we can move to the seventh question. Seventh question is about beta decay. Okay, we have already seen what is beta decay. Okay, inside that decay, an atom electron is ejected. Okay, an electron which is already present within the nucleus is ejected within the nucleus. Okay, electrons within the nucleus. Okay, and option C is a neutron in the nucleus decays emitting an electron. Okay, we know that the neutron is transformed to electron and a neutrino. Okay, we already seen that in a bismuth. In the case of bismuth, in the previous section, we already seen the reaction formula of bismuth. But the neutron from the nucleus, the nucleon, that means the neutron is decaying into what? Electron and a neutrino. So option C is a neutron in the nucleus decays emitting an electron. A neutron in the nucleus decays. Yes, neutron is actually decays to electrons. So option C is the correct answer in the beta decay, beta minus decay. Okay. Okay. Coming to the eighth question. A radioactive element has half-life of 15 years. So in here T half is 15 years. Okay, what is the fraction that will decay in 30 years? So time is given. Okay, time is given. We have to find what fraction after 30 years, what fraction will be there. Okay, actually we can do this in two methods. One is theoretical method and the second is logical method. They said that 15 years is the half life. That means if there is 10 particle, what will happen? Okay, if there is 20 particle, consider that if there is 20 particle, what will happen in the first T half? That means first 15 years, the 20 particle disintegrate into 10 particle. Okay, then another T half. What happens in another T half? That means after 15 years, that will disintegrate into 5 particle. That means after 30 years, 20 particle will be disintegrated into 5. That means 5 by 20. That is 1 by 4. Okay, so only 25% will be there. Okay, the last 25% of the initial it will be there. So option A 0.25 is the correct answer. Or we can do this by theoretical method also, because T half is given. Okay, T half is given, so we can find the constant. N is equal to n0 e raised to minus lambda t, and T half, that means 1 by 2 is equal to e raised to minus lambda t. So 2 is equal to e raised to lambda t. So lambda t is equal to ln2. So t is T half, that is given 15 years. So lambda is equal to ln2 by 15. Okay, put that in a box, and we want to find n. N0 is already we want to find n0, n. So n by n0 is equal to e raised to minus lambda t, and n0 by n is equal to e raised to lambda t, and ln, and lambda is what, ln2 by 15. So and multiply the lambda by, substitute this lambda in the above equation, e raised to lambda t, then solve it, then we get, and t is equal to 30. So e raised to 2 lambda 2. Okay, we can n by n0, which is equal to e raised to, correct, sorry, n0 by n is equal to e raised to lambda t, and lambda is ln2 by 15, and t is 30. So 30 into 15 is what, 2, which is equal to e raised to 2 ln2. We can take that coefficient 2 to the inside ln2, so that will be make the power of 2, so which will is equal to e raised to ln4. That means ln2 is equal to ln of 2 raised to n. Okay, by using this formula, which is equal to e raised to ln4, which is equal to 4. Okay, so n0 by n is equal to 4, so n by n0, which is equal to 1 by 4. So we have only 1 by 4th of the initial number of particles, that means 25%, correct? Yes, so option A is correct. We have proved in theoretical method and logical method. Okay, yes. So moving to the 9th question, light of certain frequency and intensity of incident on a photosensitive material cause a photoelectric effect. Okay, that means a frequency and intensity is specific. Okay, if both the frequency and intensity are doubled, okay, the photoelectric saturation current become, that means the current is related to frequency and intensity. Which one is correct? Or both are related? No, we know that current is related by number of electrons, and number of electrons is related by intensity only. So frequency is double, we don't want to care about that. So the photoelectric saturation current become double. So option 2 is the correct answer. Moving to the 10th question, in Rutherford experiment for head-on collision, alpha particle with a gold nucleus, that means the nucleus of gold atom. Okay, we have taken the atom of gold, and the alpha particle is strike with the nucleus. Okay, the impact parameter is, so we want to know what is impact parameter. So I will draw a graph. If this is the nucleus of gold, okay, and this is alpha particle. So we will draw a direction from the alpha particle to the center. If the alpha particle is pointed to the center, okay, so but the case can be different. Okay, if the alpha particle is going like this, then alpha particle is deflected by the nucleus of the gold atom. Then how we can calculate the impact parameter? See, this is a straight line, so we will draw a straight line which is pointed to the center. Okay, so this will be the impact parameter. Okay, so if this alpha is going like this, deflected by this, so the impact parameter is, from the center we draw a parallel to the straight line, so the impact parameter is this one. So by increasing the impact parameter, the deflection, the angle of deflection will decrease. Okay, when the impact parameter is 0, it will deflect straight back. Okay, because it is pointed to the center of the nucleus. Okay, so that is the relation between the impact parameter. So in this options, 0, first option is the correct answer. 0, the impact parameter is 0 when the when the alpha particle is bounded back, that means bounds with the nucleus. Okay, so moving to the last question, 11th question. Frequency of revolution of an electron revolving in nth orbit of hydrogen atom is proportional to, we know that time period is proportional to n cube, so frequency proportional to 1 by n cube. So option 4 is the correct answer.